first thing you'll need to do is take a quick trip to Home Depot and for about $16 pick up one of these wireless chime kits. Apart from the battery, there's two major pieces: the transmitter, which is the doorbell button, and the receiver, the larger component. Since that's the trickiest to deal with, we'll look at hacking the receiver first. This is the receiver. If you take the cover off the back and flip it over, you have easy access to the batteries and the circuit board, which you'll need to tamper with. It's held in by two screws which are easily removed. Something to note here: out of the box, most chime kits emit the standard ding-dong sound, which is 2 tones. Because there are 2 tones, it's very likely that your trigger may operate twice when you activate the button. If this is not desirable, the kit should come with a small jumper that you can place over position 8 on the strip of pins along the lower right of the board. If you only need one activation, put the jumper across position 8 before you do anything else so you don't forget. Other things to note are the red and yellow wire coming out towards the center of the circuit board. This is power from the batteries and one of the leads to the speaker. Once you've got the board out and flipped over, we'll start our hack by soldering 3 wires onto the board. The first wire needs to go into the center where our power comes in. This will provide power for our part of the circuit. The second wire will go here in the lower right-hand corner. This is a good point to find ground, or the negative side of the batteries. The third wire goes directly to the output chip and is the 3rd pin along on the top row. Be very careful soldering here and make sure you connect to the right pin. The next part of our hack will require a small NPN transistor and a 2.2K resistor. Connect the resistor to the wire that you soldered onto the 3rd pin coming from the sound chip on the circuit board. The other end of the resistor should be connected to the base or center lead of the NPN transistor. This will provide amplification for the small audio signal coming from the chip and will allow us to trigger something larger, like LEDs or relays. The emitter of the transistor should be connected to the ground wire, and the power lead coming from the board should go through a 100 ohm resistor, then in through your LEDs, and then into the collector side of the NPN transistor. Here's a circuit diagram that hopefully helps explain it a little clearer. If you want to hook up a relay instead, use this circuit diagram, substituting the resistor and the LED for the relay coil. Note that the relay you use must be able to run off of 3 volts. If the relay you do have needs more voltage than that, the top part of the relay can be connected to a larger power supply and have the grounds connected together in common. Just don't wire them up to the 3 volts off of the audio board. Hacking the transmitter is actually the easiest part to accomplish. If you take off the back of the button and undo one screw, you can pop the circuit board out. Here's a closer look at it. You can see where the 2 battery terminals were, but I've unsoldered them as I didn't need them. If we flip the board over, you can see this small black button. This actually lies underneath the button of the real doorbell and gets depressed when you push on the doorbell button. If you carefully unsolder the button and remove it, a closer inspection reveals that all the button is doing is switching the power from the battery into the circuit. This makes it really easy to hack and substitute the button with a switch or relay of your own choice. In fact, all I did was solder a black wire to the negative side where the battery would go, and a red wire to the side where the switch would have connected, and now I can switch 12 volts in to activate the transmitter whenever I want. The possibilities are endless.